So to wrap up this series, the next eval tool that we're going to look at is Arize Phoenix. It is one of my favorite open source eval tools. All right, so welcome back. We took a break. Everyone went and took a shower. They're wearing different clothes.
Except for Hamel.
Except for me. But here we are. And we are going to finish this off with Arize, Phoenix Arize. So let's jump right into it.
My name is SallyAnn, and I'm one of the product leaders here at Arize. I'm really excited to walk you through homework assignments 1 and 2 for the AI Evals course. Over the next 15 minutes, we're going to cover how to write and test system prompts, generate synthetic data, annotate traces, and identify common failure modes using an LLM. Before we dive into the assignments, I want to quickly introduce you to our 2 main products at Arize, Phoenix and AX. These 2 products work together but serve slightly different needs. Phoenix is our open source, self-hostable, and extremely customizable product. It's designed to meet developers where they're at. So whether you're working in a local Jupyter notebook or deploying in your own cloud environment. It's great for running evaluations, writing prompts, and digging deep into your application's behavior. And then we have AX, our enterprise platform that supports evaluations at scale. I'm talking billions of records backed by ADB, the Arize data backend, with SSO support, advanced observability, and team collaboration features. Whether you're a small team running heavy workloads or a large org with production deployments, AX gives you everything you need to develop, evaluate, and observe LLM applications at scale. So today I'm going to be using Phoenix to do homework assignment 1 and 2, but towards the end, we'll talk about how AX could help you complete these with the help of powerful tools like Alex, our AI agent that we've built into the platform. But with that, let's get started. So over here, I've got our code for our first homework pulled up, and we're going to be focused on system prompt engineering. So the overview of this assignment is to write an effective system prompt, expand our query dataset, and set up Phoenix for testing. The first few cell blocks here are just for our imports. We're going to want to make sure everything's installed and ready to go, and doing things like enabling nested async for our notebook. And then we're going to want to get Phoenix up and running. So I'm using Phoenix local.
It's a lot of imports. I've always noticed that. There's a lot of imports, you know.
It's true. I do like that we're seeing this getting kicked off from a notebook, though.
Yes, that is a plus.
To complete these assignments, you could opt to use Phoenix Cloud. The only real difference here is maybe grabbing your API keys from the platform if you're using cloud. But if you're using local, which I suggest you do, it's really easy to get started and you have a lot of control when you're running the application locally, is you can either run this code that I've included in the notebook or go ahead and run this from the terminal. And then once you do that, Phoenix will be running on localhost and we'll be good to go. So we have Phoenix set up. Great. Now let's do our prompt management. We're going to create a really simple prompt at first. I created something really basic here. I'm just basically telling it what its job is, which is to create recipes and cooking advice and provide it in a clear step-by-step instruction.
Plus points for showing us the prompt.
This is a baseline prompt
Also,
to have a good
I
starting
like
point.
she started super naive and simple as opposed to immediately being like, I'm going to think of every possible fuck up.
Yeah.
Yeah, definitely.
And start testing and understand how it's performing. So I'm going to go ahead and log this to the Phoenix platform just by giving it a name, a little bit of a description, and I can also log any model parameters that I want, like name. And this is really helpful for when you're maybe iterating over time. You might be experimenting with different models. We're going to be able to track that by each version that we create. So I went ahead and ran this, and then if we pop into the UI, you can see that it's been added. We've got that system prompt along with the model configuration. And from here, we're pretty much good to go.
Couple quick comments on this UI. I find it pretty easy to see what's going on here. You see like there's a product template a prompt template right up top. That feels pretty like easy to grok. I see there's a place for tools that might come into play later. I feel like model and provider are pretty like clear and immediately obvious. One thing I don't see is it says like just the system prompt. I assume that if you had other user prompts and assistant prompts, they would just stack in that first top part. But yeah, I think this is like pretty easy to understand what's going on immediately.
Yeah, it feels nice somehow, the local host, and you can kind of run it locally without feeling like there's a lot of magic.
So you'll see as we iterate, you can see all the saved versions and have that full control. Let's go back to the code. Let's create some data before we do our actual prompt iteration piece. Now, the homework assignment comes with a sample of 3 queries. So just a quick vegan breakfast recipe. I have chicken and rice, what can I cook? And give me a dessert recipe with chocolate. But the assignment calls for us to expand by adding 10 more queries to this data set. I added 10 additional queries manually, and then I'm just going to go ahead and load that into the Phoenix platform. And if we pop over here, we can see that we've got that total of 13 rows available for us. Now, if you wanted to, you could add the examples in the UI and just upload the CSV, kind of completely up to you. I like to do it in code to make it really simple. So
nice tables
awesome.
UI.
We have a prompt loaded to start with. We've got our sample data set. Let's go over to the prompt playground now and actually do some testing. So let's go ahead and load in that prompt that we've created and our data set. And I'm just going to go ahead and change our prompt variable. I'm using fstring here, and I want to make sure that the prompt can actually pick it up. So we've got everything all set up. We don't have to do any of this in code. We can just now run the prompt, and Phoenix is going to run it on each of the examples. And it's also going to track things like latency and token count and cost for us as well. So we can kind of see how that compares prompt to prompt as we iterate. But it's also doing an experiment for us. You can see here it says view experiment. So it's going to track experiments automatically so we can easily compare outputs across the runs. So it's generating as it's going. I'm going to go ahead and start reviewing some of these results, and let's see how our first basic prompt.
What if I have 1 million examples in my data set? Is it just going to run on all million? But anyways, side note.
Yeah, whenever you can do like a sampling or something.
Yeah, there might be a way to sample.
I like to, for mine, I have them so you have tags and you can sub-select down to tags, or you can sample over whatever the population that's selected from. One thing that I think is pretty cool and I haven't seen before, they allow you to select what formatting for the templating. So that it's like none, mustache, and f-string. I haven't seen that before. That's pretty cool.
Yeah, it's pretty cool.
So first question is just a question asking about how we store herbs. Overall, it looks like it's giving some different ways that a user could.
I can't read that.
Yeah, I mean, let me see. Let me try to
No,
zoom.
there's no world in which if you zoom, it's going to be any better. I just cannot read that amount of text.
Hamel, can you increase the font size in the UI? That was a joke.
I know.
Overall, nothing really shouting at me. Now, looking at this example here, it does seem like the format from the first to the second is slightly different. So usually you want to make sure you have a really consistent user experience. So that might be something that we want to keep track of and iterate.
Yeah, I mean, this kind of goes back to why you want to build your own annotation app or your own data viewer a lot of times, because you have domain-specific data. It's not really too domain-specific even, but it's like, hey, you want to, read it. Like Shreya saying, can't read this that easily.
Yep. Also, we talked about this in a previous video. There's no Markdown rendering on these. I would love to know if you click that expand. I see there's an expand icon, but I don't know if you were to if you hit the expand icon, if that renders the Markdown. That'd be nice, especially because we know that these models output Markdown like crazy.
Yeah, maybe I should click on it and see.
Yeah, that'd be nice.
This one too, again, super short. We're seeing such variety in terms of output. The other thing that I'm noticing is there's a little bit of a lack of a personality. The bot's just kind of responding. It's not really asking if there's any kind of follow-ups. And sometimes it feels like it's being either super specific or a little bit more general. So I think I need to give it some personality, and I think I need to give it clear instructions on how it should be responding and exactly what styling it should include. So what I'm going to do is I'm actually going to go ahead and push compare. And what that's going to do is add an additional prompt to our playground. And why this is so powerful is now I can go ahead and take 2 prompts side by side, run them on the same data set, and be able to compare how they are performing and how they're differing. So this is going to be really great for your iteration workflows. I'm going to go ahead and pull in a prompt that I already kind of set up for us here and pop it in to the playground. So let's kind of at a high level understand. So right away, this system prompt is a lot more detailed. It's explaining what the core responsibilities are, outlining what the guidelines are for ingredients and instructions. It's giving it a little bit of a personality and saying what it can and cannot respond to, as well as the style formatting. Those are going to be really key when you're creating
Good job
good
reading the
system prompt. Is you're going to want to make sure you're explicitly telling the LLM what to do, what its responsibilities are, and how it should respond. And what we'll see as we run this is hopefully now that we have added in all of those additional requirements, we're going to start getting more consistent results and better outputs. So we're seeing the results come in.
I have a slightly spicy take. If you go back just like a few seconds to where you can see the two system prompts next to one another.
Yeah.
Every time I built a prompt library, from the very first time to the most recent one I built, every single time these things in the system prompt are components. They are components that you plug in. And I have always wanted to basically ablate each of them and say, if I ablate the part where I say core responsibilities, what happens? If I ablate ingredient guidelines, what happens? I haven't seen that in any of these demos. And like, maybe I'm like being too obsessive about what's in my prompt, and maybe I'm overthinking like the stupid components, but I get really, really like anxious that if I don't kind of one by one ablate these, I don't really understand what's happening in my prompt. So that's just a personal feeling that all of these probably can do because they have variables, but I still find myself wondering, why are we writing massive system prompts that are just plain text as opposed to components? That's
I think it also is in line with the principle of have the least complexity, or even to go even further, Occam's razor from, your machine learning mentality. And I think that is a reasonable comment. Like I have that same bias as well.
Anyway, that was my soapbox moment. Sorry.
Yeah, no, I think that's a really good observation.
Yeah, I like it.
Requirements, we're going to start getting more consistent results and better outputs. So we're seeing the results come in, and now let's start doing some comparing. So taking a look at these results, the first ones seem pretty comparable, but you'll definitely notice that a lot less text. So at the beginning I was saying it's very wordy.
I can't notice.
And now I feel like, okay, maybe we're getting a little bit more consistent results there. You can also see right away that the formatting from the first to the second is consistent versus before, where it was a little bit inconsistent with how it would present. Even for things like the general questions versus the recipes, you can see that formatting is really consistent.
So surely, maybe this is just a constraint of the demo, but surely she had to render this somewhere else and do this comparison. I think that's the only thing I can think of that has happened.
Yeah. Yeah, apparently Markdown rendering is like a killer feature. I'm like obsessed with Markdown rendering suddenly.
Yeah, definitely.
I'm also seeing that it's having a little bit more personality. It's stating why it's picked a recipe, or kind of at the beginning. You see here where it says it's renowned for its rich flavors, understanding spices can help your cooking. So I think all in all, we were able to really improve our results by adding in these additional responsibilities and the instructions here.
If you go back just like a few seconds, if you just scrub back a teeny right here. Okay. So they're showing these statistics. We've got like the time and the number of tokens and the price. Cool. Totally fine. Reasonable things to look at. But this is where I'm very much a like data visualization maxi. I want to see the distribution of those numbers at the top as little like numbers or distributions. Like just show me little histograms of like, what was the time of each of these? What was the cost of each of these? How many tokens? Because if there's one that's way out of distribution, that's interesting. If there's like a bimodal thing, that's interesting. If I care about these numbers, I only care about them in context. And I don't know what to do with 1,000 tokens as just a like point statistic for this one particular prompt response. I don't know if I care or ever will care, but I do care if you tell me that like some subset are really long and some subset are really short. Now I started being able to do things with it. So I find myself immediately wanting some aggregation shit. When I build this, I tend to build like those aggregation charts on as part of the initial view.
It's going to be really difficult, I suspect, to compete with notebooks. In fact, Bryan, you and I might do a bonus session about
Just do the whole thing with notebook.
With no tools, which is we actually have somebody that we recorded that has done that. We can do that if you'd like.
Okay.
I would say one thing further. I agree with you, Bryan, but I also think that these metrics are like the least important metrics at this stage to look at. Like, do actually read your data. Don't care about the number of tokens at this point.
I agree. I certainly am only looking at like token output when I'm starting to worry about certain specific things, not at the moment of like experimenting with the thing. I don't know. Yeah.
Yeah. I mean, I think your more general point is that, hey, by putting these statistics on the rows, they're more sort of eye candy than they are informative if you were to see an aggregate score.
And we did see that in in Langsmith as well. I don't remember if we saw it in BrainTrust, but I definitely saw it in Langsmith.
Yeah, to be honest, I don't remember at this point anymore.
Flavors, understanding spices can help your cooking. So I think all in all, we were able to really improve our results by adding in these additional responsibilities and the instructions here. So what I can now do is go ahead and save that. It'll go right as part of that initial version. And if we go back to our prompt over here, what you'll see is we'll now have an additional version available to us.
Big fan of versioning.
All right, so now that we have our prompt, we're ready to move into homework number 2, which focuses on generating additional data and doing more systematic analysis. So we're going to do this in 3 parts. The first part is going to be focused on generating synthetic data. Second, we'll run that prompt that we just created on all of those new queries. And then we're actually going to annotate the results and try to identify where there are maybe failure patterns. We'll then generate our taxonomy for our failure modes so that we can understand what those common failure points are. So step 1, of course, is just going to be to set up our imports. I'm then just going to get my OpenAI key set up. I'm using that for the synthetic data generation, but you can, of course, substitute that with any model provider that you'd like. Now let's get into the data generation. So the first step of this is identifying key dimensions. So the assignment asks us to create 3 to 4 key dimensions relevant to the functionality of the recipe bot. Now, I've gone with dietary restriction, cuisine type, meal type, and skill level. You can, of course, adjust these to be whatever it is that you would like. Now, this is going to give us hundreds of possible combinations. You can see here I've created 450. But we're going to use that to then create unique combinations. And to do that, we're going to just grab 25 of those 450, and we're going to create these. So you can see here are some examples as we're just kind of grabbing a few combinations of those. And then once we have that, we're actually ready to do the synthetic data generation. And the way we're going to do that is actually using Phoenix's LLM generate function.
Why are there emojis in the print statement? I don't know, but we can, we don't need to nitpick on that.
I have a hunch.
And I really want to highlight why using LLM generate.
That I'm a little confused about. My understanding of the exercise was these were the dimensions on which you're going to be evaluating its correctness of output. These are not necessarily dimensions. Like, it sounds like she's going to be designing data to span these different dimensions.
Yeah.
Is that correct? Is that
Yeah.
Okay.
Yeah.
So the purpose is like generate a diverse set of synthetic queries. And one way to do that is to come up with whatever dimensions that you think will have some variance, create queries out of them, and then go do error analysis on the traces generated from those queries.
Okay, cool. Thanks.
In the real world, you probably wouldn't make it as random. You would have some hypotheses and you would say like, oh, like I'm going to go here and there and I'm going to like I think it's going to break if I do X, Y, Z or ABC.
Yeah.
But you know, it is a homework assignment, so I try not. I didn't go that critical. It wasn't that critical of it, I guess, yet.
Is so powerful. And it's really because it handles all of the messy orchestration. Async calls, retries, rate limits. It's going to work directly with the data frame and templates. So you just kind of pass it those dimensions in a prompt, and it's going to give you the structured results without any extra parsing. So it's just going to make this process way easier for us than if we were going to write this all from scratch. So I'm going to take those 25 tuples that I've created before. I'm just pretty much formatting it into a data frame. And then I've created this prompt for our generation. And then once we do that, we can just go ahead and pass that here. And in the end, we're going to get some different query outputs. So we've got our 25 diverse synthetic queries. So we're good to go there. We just got to get them into the platform. So again, we're going to go ahead and run our upload dataset call.
I feel like the integrations aren't nice, like in Lanksmith, you know, where it's just like one decorator or like one line logging, or even in Brain Trust. Here it's like kind of generate a pandas data frame of my data and then like run some other function to do the upload. I don't know.
One thing that, I mean, I have used Phoenix quite a lot, and one thing I like is it does actually have, I always have pandas data frames because I'm so Python pilled
You're
at this
already in
point.
notebooks.
And I'm already in the notebook. And so like, it just works. When I look at the docs, it's like, oh, this is what I'm doing already. So I'm super biased in that sense.
So back in the UI we go, just to double check on those data sets. You can see that it uploaded here. Let's test it in the playground. So I'm just going to load that data set into the playground. I'm going to go ahead and choose that prompt that we just created. You'll notice that it automatically pulled in the latest version for us. And all we have to do is run it. And I mentioned before, an experiment is going to be automatically created for us. So let's go ahead and take a look at a few of those now. So going ahead and looking at these, what we want to do now is use the free text annotations to form the basis of our error analysis. We want to review each output, noting where the prompt didn't meet our expectations. So we don't want to simply just say wrong. We want to describe the issue. Like the user asked for a quick recipe. This recipe is requiring something that takes a lot of time. So let's go through a few of these now. This is a great example. So as we're looking through this user asked for an advanced vegan lunch that captures the essence of American cuisine. So right away looking at this, they asked for something vegan. I'm noticing that there's heavy cream and parm, definitely things that are not vegan. So what we can do here is type in the notes that say, ignores dietary restrictions. And so we don't really want to say again that this is wrong. We're trying to explicitly explain what it is that is wrong. So we can kind of continue to go.
One thing, I have like two questions already. So one is I wonder if you can highlight text and then leave an annotation on the highlighted text. That's been something that I've really appreciated that I use. And the other thing is, I don't know what annotation configs are. I'm seeing this like no annotation configs for this project. And I find myself wondering, what is this?
Yeah, annotation configs are like if you want some structured fields to do annotation with, like you want a drop-down menu with some values, want a binary value, whatever, you can kind of pre-configure it so it shows up in the form there, essentially.
That's pretty cool.
Yeah.
Nice. Okay.
I think they all have something like that.
I see. Okay. Cool.
Through, and what we want to do is essentially continue to try to identify areas where perhaps the application got it wrong. So I've kind of gone through and annotated the full data set. So let's go back to our code to finish off our assignment. Great, so now that we have all of our data annotated, we can actually go ahead and export that data back into our notebook so we can start creating our taxonomy. So I'm just gonna go ahead and export that data from the platform. you can see here, we get our free text annotation in our results.explanation file.
I really like
here.
this already.
And so what I'm going to do is, rather than sitting here and kind of combing through all of the explanations and trying to come up with patterns myself, I'm actually going to use an LLM to do it. So I'm going to go ahead and create a simple chat completion, and I'm giving it a prompt with all of the data, and I'm just asking it to come up with some labels that represent the data.
I actually really like the integration with the notebook. It just feels clean and like I can control where I'm at the workflow. I know previously I said I like doing everything in the interface, but maybe I'm having a change of heart. I don't know.
You should check out this website called notebooks.club.
As if I've never seen it before.
Yeah, I mean, you're just reminding yourself of your love for notebooks, which is understandable.
And so what we're going to get is a list of our labels, with each data point being a failure mode. And what we can then do is use LLM Generate again to label each data point with the corresponding failure mode. And then once we get that, we can kind of analyze to understand exactly where the most common failures are. And we're actually going to save this off for use in a future assignment.
So just to clarify, each vendor, you can use it with a notebook and read and write from it. I just think that in Phoenix, that's what they are oriented towards.
Got it.
Like that, like all their examples, and that's kind of how they have like a data science-y aesthetic to everything.
Yeah.
The one comment I'll make is I think Arize is sort of like an older LLM ops company, and so I think they came up a little bit more in the ML ops era, and so maybe that informs why the form factor is a little more like DS.
Yeah.
And so that's going to be homework assignments 1 and 2. To summarize, what we did today is we wrote an effective system prompt. We did that by iterating on the platform. We built a synthetic data set. And then we were able to create a taxonomy using annotations from reviewing the underlying traces. Well, we used Phoenix today. Everything we did can also be done in AX with additional enterprise features. Alex, our AI assistant, can generate prompts and data directly in the UI. And we also have LLM as a judge evaluation that can run in the playground as you're iterating. So you can get a free account today and start exploring these tools. In assignment 3, we're actually going to use AX directly to scale these workflows. So this wraps up our walkthrough for homework 1 and 2. Hopefully this gives you a strong foundation for using Phoenix for prompt-based evaluation and trace analysis. Feel free to reach out to me or to our community if you have any questions, and I'll see you in the next one where we dive into AX. Thanks, everyone.
Pretty like to the point.
I learned about my love for notebooks once more.
Back on the bandwagon.
It's always there. You just have to recall it.
Yeah. I felt like Arize was the most like direct and like it felt really streamlined. All the steps felt very clear of like how you would go after it. Maybe now I'm just conditioned by the first 2, but I don't know. It felt very, very clear on like what the next step in this process was. Less extraneous things going on. I don't know.
Yeah, I mean, it's hard because it's biased pretty well towards data scientists, and we are all data scientists.
Well, we are all everything, so.
Yeah, okay. But it has some affinity, I think, special affinity towards the data thinking, I think. And, it's a very comfortable workflow that makes sense. And yeah. And then also I have a soft spot for like open source, and I like to be able to hack things, hack the back end, the database that is writing to, and see it, do SQL queries on it even, like write to the SQLite, and then something like, let's just query it, and do all kinds of things like that.
I will say I don't know how the production support is going. Like I definitely don't have data frames running in production, so I wonder how that. I'm sure they thought about it.
Yeah.
Tell me more about that, the production data frame thing.
Oh, like, if you're generating real-time traces and you want to log them in real time, right? The trace is not in a data frame. You're not like uploading a data frame. So some other logging util probably needs to exist.
anything can be a data frame if you try hard enough.
Okay, I don't want to make things a data frame.
You know what's really funny? I make everything into a data frame.
Same.
Like I don't know. I like everything. It's just a comfort. Like I have like methods on stuff to make it render into a data frame. It's like,
Yeah.
So maybe a toxic trait.
Awesome. Okay, so before we go, Shreya, what was the standout for you?
Oh man, I have to say I liked Braintrust UI. I liked Langsmith's, vibe of like being product analytics and data and error analysis all in one. And I liked the notebook-centric data science aspect from Arize. So
Awesome. Hamel?
Yeah, there's not a landslide victory here. I think there's something good about each platform that's like unique. I would say like Langsmith has a really strong annotation queue that I really love. I like their playground a lot, how you go straight from trace directly into playground, like right away. Of course, we're using LangChain, LangGraph, or anything like that. You can't beat it. I mean, you're not going to get better integration, obviously. And there's some other UX things there that are quite good. And then Braintrust, I really like the UI a lot. Like it just feels nice. And yeah, I would just echo. I'm a data scientist, so for data scientists, I like, if I'm coming from a, let's say, Python data mindset, I like the Phoenix aesthetic.
Cool. Awesome. Well, thanks for doing this with me.
Wait, but what about you, though? You can't get away with making a judgment. What's going on?
Yeah, I think I found the UI the most straightforward to understand in Braintrust, but I think my workflows fit easiest into Arize. But I'm not going to pull any punches. None of these are nearly as useful as the one that I built myself. And not because like it's better than these, just because I built it and it's like exactly what I need for my tasks. All of these feel like I would spend more time learning how to use them than I could just augment what I've already got to be what I need. And I can't imagine investing in any of these until I really was hitting some like production blockers that made it feel like they were going to be super valuable. And
by that time you hit the production blocker, you would have so much information that you would be able to evaluate the tools. You would have some real requirements at that point. You wouldn't be just kind of vaguely like baking them off.
Exactly. Yeah. Awesome. Well, thanks everyone. I'm really, really appreciative you doing this with me. This is super fun.
Yeah. Thank you.
Cool.